In this case study, we are going to look at some categorical variables. So first of all, when you open your data set, so here we have our SPSS data file relating to the survey that was conducted by Tourism Florida, the DMO for the state, trying to understand more about those who are taking different types of vacations and whether they have children or not. So if you recall, the question that they came to us with is, if what are there any correlations, right? If there's a correlation between the type of vacation that people are taking and presence of children, that is, they either have them or they don't. Is there a relationship between the two of them? So 150 responses were collected, and we can confirm that here by looking at our data view and scrolling down. You see 150, and the following variables were collected. They got an ID, their age. Both of these are coded as scale, right? This is ratio, age from 0 to whatever, and ID from 1 to the 150. So we have all of our IDs. Remember, ratio means you can't have less than 0, right? So you can't be less than 0 years old, and you can't have less than 0 people. And so these variables are all coded as nominal. So we have sex, occupation, presence of children, type of vacation, and income level. Arguably, you could actually change that income level variable to ordinal, right? Because we have treated it as low, medium, and high. And you could easily argue that a high income is more than a medium, which is more than a low. But because the distance between them isn't measurable, we don't know if high means $1 million, 10 million, or $100,000, right? So because we can't really measure the distance between them, we can't say it's interval scale. So this would be ordinal in scale. Okay, so this is our data. If we switch to variable view, you can see the 7 variables here listed with all of the correct inputs as they are laid out. So what we're going to do in this video is we're going to do a chi-square analysis, right? So we want to know, if you recall, or a research question, we want to know, is there a correlation between two categorical variables? In this case, we want to know, is there a correlation between presence of children and type of vacations that they're taking? So the null hypothesis is, in this case, there is no correlation, and the alternate hypothesis is there is a correlation. So essentially, we're seeing if there's any associations here. Okay, so if we go to Analyze, Descriptive Statistics, Crosstabs, this is where we're going to do the analysis for today. So difference between rows and columns really depends on what your research question is and what you're trying to really understand about your data. So if you're trying to understand, of those with children, what types of vacations are they taking, you would put row and column. And I'll show you here how that will look. Okay, so leave all the other settings. I'm just showing you. If we click on Display Clustered Bar Charts and hit OK, and we scroll down here, you can see that it's saying of those with children, X number looks like, it's hard to tell exactly, but I would say maybe 12 or 20 took a beach vacation, and maybe 52 or so took a Disney vacation, right? So those are horrible guesses. I'm sure the actual numbers are quite different. So actually, here we have beach with children was 12, and beach with Disney with children was 54. So that's here. So with children is here, without is on the right. So the reason I'm showing you this is just to say that you can do a comparison this way. You can look at your data like that. Or if we go back and we switch these, so now we have vacation in the rows and children in the columns, it inverts that. So now it's saying, of those who took a beach vacation, how many were with children and how many are without? And of those who took a Disney vacation, how many are with and without, right? So here we have, of those with children, how many took a beach versus Disney, how many without took a beach versus Disney. So it just depends on what you are trying to understand. So in a 2x2 matrix or a 2x2 crosstabs analysis, it's not a big deal. Either of these would work. But when you add in a 3x2, for example, say we're comparing income levels, and you have multiple of them, it is important to make sure that you set this up correctly so that you're not confusing the data. All right, so let's go back to descriptive statistics, crosstabs, and we can keep it either way, but I'll do what I had originally. So have children in the rows, vacation type in the columns. Now we're going to set up our analysis. So if you recall, if we go to statistics, if you recall, we're doing a chi-square analysis. So chi-square, we're going to check the box. These nominal values are what are called the coefficients. These are the strengths of the associations. So assuming that we have a correlation, and we'll also check, by the way, this correlation box. You can do that. You can also leave it blank because the chi-square will give us anyways, but this is a good visual check as well. This will tell us the strength of those correlations. So phi or phi and Kramer's V are the two most commonly used, so we'll select those. I'll also include the contingency coefficient just so you can see it as a comparison value. So the difference between phi and Kramer's V is phi you'll use when you are looking at a 2x2 table. So if we have, for example, in our case study, we have with and without children, and we have vacation Disney, and we have vacation beach, right? So it's 2x2. So in that case, we would analyze the phi value. If there were 3 vacation types and 2 children, it becomes a 3x2 table, and anything above a 2x2, we analyze Kramer's V. Well, the good news is that it will give you both at the same time, so you just select that checkbox, and it'll make sure it includes both of these. Okay, we'll hit continue. Next, we'll go down to cells. And here we want to tell SPSS what we want to count. So the observed counts are the actual values. So if you had just kept this checked and hit continue, you would end up with essentially just a 2x2 table, right? So it would just be the counts of how many with children took Disney, how many without children took Disney, how many with children went to the beach, and how many without children went to the beach. But we want to get a bit more information. So to do that, we're going to check this box called expected. Expected is what SPSS thinks would be the probability of counts in each of the boxes, right? So for example, if we were to flip a coin and you ended up with, flip a coin 6 times and you end up with a heads 5 times, you might think that there's going to be a tails the next time around, but that's not how probabilities work, right? It's a 50% chance each time. So SPSS thinks about that and thinks about what do they expect those values to be based on the information that's given. Okay. We will also get some percentages. So we'll get a row, column, and total. The table will look a little busy, but it's good to have all this information to make our decisions from. Okay, and then the z-test. So the z-test, it will compare the column proportions. In other words, it will say within groups, are there any measurable differences, right? You can think of it as kind of like a t-test for a crosstabs distribution. So if we click that and select the adjust p-values, that will give us some additional information where we can say, for example, of those just with children, how many choose beach versus Disney? Or of those who just go to Disney, how many have children versus don't? Right? So if we're not doing a comparison in a 2x2 context, we just want to look within one of the categories specifically, we would do this z-test here, right? Keep in mind this only works in this case for a non-parametric test like the one we're doing. Otherwise, you would do a t-test or an f-test, f-value, right? F-ratio. In a ANOVA or something, depending on the number of variables. Okay, we'll also collect some of these residuals. So we'll get unstandardized and standardized residuals, and I'll show you what those look like in the table. So we'll hit continue. Once everything else is set up, remember to keep this box checked, display clustered bar charts. It's not set by default, so make sure you check it if you're just starting from this point, and hit OK. So here are our results. So we have 150 respondents, which is great, no missing values. I want to scroll down to the bar chart. So again, this is a nice way to confirm that these are the variables that we're looking at. So we're saying of those with children who took a beach vacation versus a Disney vacation, and vice versa. Those without children who took a beach or Disney vacation, right? And right off the bat, you can see that there appears to be some kind of a correlation here, right? So we have to still analyze it. We still have to go back to the chi-square numbers and the significance levels measured by alpha in this case. But you can see here that clearly is some sort of a pattern going on regarding whether they have children or not and which type of vacation that they're taking. Okay, so we'll come back up to our crosstabs table. So here we have those comparisons. So you can see that we have 12 beach vacation goers with children. If I were to ask you, of the total of all respondents in the study, how many went on a Disney vacation with children, right? So you just need to look in the table and know what you're asking. So it's saying of your total, so we have a total of 150, right? How many went on a Disney vacation, I believe I said, with children. So we look at percent of total with children. We move across to Disney, and we can see that the value is 36%. So we can either report that as a percentage or a value. So 36% went of our total went on a Disney vacation with children, which represented 54 of our respondents. And look how far away that is from the expected count. So SPSS thought there would be about 30, when in reality we had 54. So it's quite different, right? That difference is important because what SPSS is doing essentially when it makes its chi-square test is looking at the significance of that range of values, right? Removing the expected from the observed. So here we have our chi-square test. So the first thing we would do is look at our asymptotic significance, and that is represented by alpha. And here we can see it's less than 0.001. So in this way, we would say that there is a significant correlation, right? It is below our 0.05 cutoff or 95% confidence interval, and therefore this is a significantly significant result. But how big was the chi-square value? So we move over to value, and we can see that it's a 63.305. So this is how they reflect the value itself. Degrees of freedom in a chi-square analysis is rows minus 1 times columns minus 1. So we have a 2 by 2 table. 2 minus 1 is 1. Another 2 minus 1 is also 1. 1 times 1 is 1. So just keep in mind that's how degrees of freedom are calculated in a chi-square. Okay, we still can't say for sure how strong the association is, but fortunately, even though we're doing a non-parametric test, we can refer to this symmetric measures box here or table, and it will tell us the strength of the association based on nominal data, right? Which is pretty cool. So it says here that our phi value, remember we measure phi when we're looking at a 2 by 2 table. If it's bigger than a 2 by 2, we actually go down to Cramer's V. It's adjusted to account for the difference in sample size. So here we have a phi value of negative 0.650, and if you refer to our chart, this is a moderate to high correlation, right? A negative correlation. So it's saying that there's a moderate to high negative association between children type and presence of children, presence of children and vacation type. Okay, so that is essentially a crosstabs or chi-square analysis